Hey everyone, welcome to the Intro to Web APIs workshop for Hack on the Hill. I hope that your projects are going well and you've added some cool features so far. But if you're looking to add a couple more cool features, you come to the right place for this workshop on the Introduction to Web APIs. Today we're going to be going over this workshop, and the slideshow for the workshop is provided right here at this tinyrail.com link. You can access this link and follow along as we go through these slides. Additionally, on the bottom left of every single slide, we're going to have this README link right here for another tinyrail.com link. And at this README, you can find more detailed instructions and explanations for everything in this workshop, including full code segments for the demo that we'll get into later in the workshop. So today we're going to be going over a couple different things, including the client-server model, understanding what APIs are and what web APIs are. We're going to be doing an overview of HTTP requests and responses, as well as some additional extra stuff. And then with that, we'll get into the demo for web APIs. So before we get into actual web APIs, we need to understand what the client-server model is. This is a really fundamental system design architecture that's essential to learn before knowing what web APIs are. But what even are servers and what are clients? You can think of clients and servers as computers that keep running. Clients ask servers for some information or to complete some task through things called requests. And then servers respond to these requests made by the servers through something called responses. It's a two-way relationship where servers are made to serve clients. And to easily understand these concepts, we'll use a running analogy of a restaurant throughout this workshop. In a restaurant, customers and patrons are clients, and the kitchen is a server. Similar to how clients make requests to a server to have some action be performed or to receive some data, customers can order different dishes or maybe even make special requests to the kitchen. And then customers would receive that food from the kitchen. What makes this model so powerful is the fact that many clients can access the same shared resources just through one server, like how many customers can order many different dishes from the same kitchen. Additionally, servers do all of the hard work by hiding all the complexities from clients while completing the client's requests. This is similar to how a kitchen makes all the food for its customers behind closed doors. This is an example of abstraction, a term that you might have heard of in computer science. From the perspective of the client, the server just receives a simple request and suddenly some complex operation is completed and the client is happy. But at this point, you might be wondering, is there another important element missing from a restaurant analogy? How are APIs even involved? These are valid questions and we'll answer them in the next section. So in a restaurant, customers typically don't directly communicate with the kitchen. That's the role of the waiter. Waiters take orders from customers. They inform the kitchen what needs to be made and serve customers food that's made from the kitchen. They act basically as the ultimate middleman between customers and the kitchen. So in our analogy, waiters are equivalent to an API. They are the middleman between clients and a server. Yeah, as I said, as waiters take orders, they tell the kitchen what food to make and they serve food to customers. The API does so for clients and servers. An API basically stands for a application programming interface, and this is like a fancy acronym, but in general, you can think of an API as just basically a way for different software components to interact between each other. But for what we're interested in, it's more of like a two-way channel of communication between clients and a server. But what are web APIs? Specifically, web APIs is basically a communication channel over the internet that uses the HTTP protocol. To understand how web APIs fit into our client-server model, let's say if we created an app or client that uses a web API made by Google, then our app is the client, and then Google's web API services would be the server in this case. So now you might be wondering, what is HTTP? You can think of HTTP as the language that web APIs speak. They define how requests are made and how responses are structured. In our analogy, HTTP is equivalent to the ordering process in a restaurant. Customers don't just shout random food names. They instead place orders from a menu. So the waiter or the API in this case understands these orders, which in this case would be HTTP requests, and eventually they bring back the food to the customers in the form of HTTP responses. Waiters must follow this ordering process the same way that web APIs must follow the HTTP protocol. And HTTP is a fancy acronym that stands for Hypertext Transfer Protocol. But you don't have to worry too much about this definition. But you might have heard of the term HTTPS. This is the same thing as HTTP, but basically more secure. And as we mentioned, HTTP defines different requests and responses, which is the core important idea of HTTP. So to get more into something like an HTTP request, we have an example of one right here. An HTTP request is made of several components, including a method, a URL, headers, and a body. So let's get into each component. To start off with a method defines what type of operation the client wants the server to make. Also known as CRUD operations, which stand for create, read, update, delete. The four most essential and common HTTP methods are get, and get means it's basically a request to read or access some information from the server. We also have a post method, HTTP request, which indicates it's a type of request to create new data on the server. We have put, which means it's a request to update existing data on the server. And then finally, we have delete, which is a request to delete existing data from the server. Next, our next component is URL, the URL. This basically specifies where the request should go and what to retrieve. It's typically made of a few different components. And sometimes you would find the protocol used like HTTP or HTTPS next to the URL, or sometimes you might find it next to it in the HTTP request component decomposition. You also might sometimes find the domain or host. In this case, that is example.com. And then you also might find the path. In this case, that's API/orders. And then sometimes there are also optional query parameters with some question mark, equal sign syntax that you might have seen before. And these just provide extra details for the request, and they're optional. But these different components make up the URL. And don't worry too much about what each of those terms means. Just know that the URL specifies the location of the request. Next up, we have request headers. Request headers are optional additional details that are provided as a part of the HTTP request. Typically, we have things like content type. In this case, we see that where we specified that the content type is application/JSON. We'll learn more about what that means later on. But you also might see things related to authentication or maybe even content length, things like that. We'll see better examples later on. And then next up, we have the body of the request. This is also optional, and it's important to note that bodies are never present in get type requests. In this case, or in general, a request body basically contains data being sent as a part of the request. So for example, if the client wants to let the server know, hey, this is the user who just logged in, this is their information, we're going to be passing that information to the server so the server can handle that user. In this case, we see that we're passing this interesting structure here with curly braces and then a name value pair of data to a string ABC123. And we'll understand more about this structure later on, but this is just what the client would be sending to the server in a readable format, basically. One thing to note is that these component definitions aren't super strict at all, and they really differ across different online examples. So just focus on the concepts themselves rather than memorizing the different components. Now let's move on to HTTP responses. Again, as I mentioned, after handling a received request, a server will then send a response to the client in the form of a HTTP response in the context of web APIs. And these consist of simply a head and a body. So for the head, this basically contains metadata about the response, and this includes headers in the same way that we had request headers, we have response headers. So you might have something similar like content type. In this case, it's text/HTML. And then we have another important thing called the status code. as a part of the head. And statuses are represented by three-digit numbers. And these three-digit numbers are the status codes. You've heard of error 404, right? The first number of the status code actually indicates the type of number, type of status indicated. So, for example, if the first number of the status code is a 1, that means it's an informational status where the request was received but is still being processed. If it starts with 2, that means it was successful, where the request was received and processed successfully. And then if it starts with 3, that is a redirection, which means the request was received, but it was redirected to someplace else, or maybe some additional action must be taken. And then we have the number 4. If it starts with 4, that means it's a client error, which means the request wasn't made correctly by the client. And then finally, we have the number 5, which indicates that the status code corresponds to a server error, meaning that the server failed to complete the request. And yeah. And now the next component of a HTTP response is the response body. And similar to the request body, the response body basically contains any data or files that are meant to be sent back to the client as a part of the response. So for example, let's say the request gave the server some information about the user, as we mentioned, and now the server handled that user, they processed the user correctly, and now basically the server might want to send back something to the client indicating that the uh, user was handled correctly. So we might have a simple HTML instead of like a hello world statement. Maybe it would be success or user was correctly processed. And then the client can read that HTML and understand that the um, response was successful, and they can also just refer simply to the status code 200. Again, 200 indicates that it starts with 2, which indicates that it is a successful HTTP response. Now, before we get into the demo, there are a couple of things that I want to clear up relevant to web APIs that aren't strictly necessary, but are fairly fundamental and good to know. So you might have heard of a term called JSON. JSON stands for JavaScript Object Notation. And this is something that's really common in web technologies. And it's also the common format for exchanging data with web APIs. It's the go-to format used in the body section of HTTP requests and responses. And while JavaScript is in its name, it can basically be used by almost any language, so don't worry about too much about that. They're formed by human readable text, consisting of name value pairs and arrays, similar to a dictionary. So if you take a look at the example on the right here, we can see that it basically contains a bunch of key value pairs or name value pairs, where the key is always the name, sorry, is always a string, and the value differs of different types, including strings, booleans, integers, and null, and even arrays. And we can also even have a JSON as the value, so we can have a string corresponding to a new JSON of a similar format. Something else that's pretty important is when using web APIs, you can use web APIs to access cool features with just a few lines of code. For example, we can create let's say, a simple front end that lets you post a tweet to your Twitter account using the Twitter API, where a button click leads to making a request to the Twitter API. In this case, uh, that is a request to the Twitter API server. And in this case, your front end is the client, and the Twitter API server is the server. But many web APIs have an online dashboard where you can create a unique API key. This API key is essentially a secret password that you send along with your HTTP requests to the server, which basically lets the server know that you're authorized to make requests to the server. If this API key is wrong or if it's missing, then the server thinks that this is some random person trying to access their cool functions, and they won't let you access them. So the API key is very fundamental here. If you do use the API key in some sort of online published repository, like a public GitHub repository, you do need to look out for .env files. This is a way to hide your API keys from the entire world. Otherwise, the entire world can access your API key and then call functions to, your servers out there and then pretend that they are you, basically, which is a huge security concern. So make sure you use .env files or other forms of protected variables to prevent this from happening, and we'll look into this more in the demo. So yeah, for that demo, actually, we're going to be looking into the Spotify web API. So our goal for this demo is to steal Spotify's search bar and add it to a simple React app. So if you aren't familiar with React, I would recommend checking out our other workshops. We will likely have a React workshop, and you can check them out using this link, or you can also just look up some basic React tutorials online. Um, but if you don't know too much about React, you can also just try to follow along to understand how the Spotify web APIs work and how web APIs in general can be used. Um, and also, if you do want to follow along with this demo requires you to have a Spotify account. So just make sure you know your login credentials and know that both free and premium accounts both work for this demo. And feel free to follow along at your own pace. You can also, again, as I mentioned, visit this README. This README contains all of the finished code segments as well in this demo that you can find on the bottom of the README. And you can also find our the demo actual code files in this repository that the README is contained in. So feel free to check that out as well. So yeah, let's get started with some basic project setup. So first, to get started, we're gonna have this to run this command. So open up your terminal. In this case, I'm just using VS Code, which you probably are familiar with. And here we just have this like folder opened up that I opened with open folder. And we're gonna open a terminal, which we can easily do with that. And I'm running Windows, but if you're running on Mac or any other operating system, the commands will be exactly the same. So to get started, we're going to enter this command, and this basically creates a Vite React project um, using the latest version of Vite, and we're just going to call it Spotify demo. Um, and then we're going to be using the basic React template just to speed things up here, and just click yes for all the prompts. And now, as the terminal says, we have our project created, and we can run these commands to get our project started up. So yeah, let's go into our project. Let's see. Okay. And then, yeah, so we can run npm install. And if you're familiar with npm, this basically just installs the necessary packages that we need to get our server up and running, or our project up and running from the node package library. And this may take a few seconds here since um, the basic packages are pretty hefty, but they're now contained inside this node modules folder. And in general, I wouldn't recommend touching anything inside this folder. Leave it as it is. But just note that all of our packages can be found here. And with that, we can also just if you're curious, run npm run dev. And what that does is actually it runs our React app. So we can see how it looks right now. So right now we see this basic template. It gave us some starter code. We can like fool around with this, but we're gonna delete all of this actually. Um, so let's see the project that got created here. We can go inside the folder and then go inside source. And this is our main project code right here. What we want to focus on is main.jsx, app.jsx. Then we also have some CSS files right here. So in main.jsx, we're going to create we're going to remove the initial components in these files and delete some of the styling. So yeah, let's do that. We're going to remove this line. We're going to delete this file. We're going to go to this file and then delete all of that. And then lastly, we're going to remove this. We're going to remove all of this starter code up to the empty brackets there. And then, yeah, we can also delete these two lines right here since we're not using those assets anymore. And then we should be good to go. And then right now, if we run our project, we would have a blank application, and that's what we want. So now we're gonna add a simple like title text element. Go back, my Spotify demo, something simple. Oops. Okay, now let's add a button. And we'll see this button or what we'll do with it later, but for now we'll just call it authenticate. Uh, we'll handle this in a second, but for now we need to, yeah, if we run our project, it would look something like this, just a blank screen with the title. You can see it right there. Now we're actually going to set up our Spotify app. So we're going to log into the Spotify developer dashboard, and I'm already logged in right here. But as you can see, I'm logged in. Make sure you log in with your Spotify credentials if you're following along. And then we're going to go to our dashboard, which we're at already. Then we're going to click create an app. So we're going to fill out the fields as you like. As we like, my amazing demo. This is the description for this amazing demo. Website we can ignore. For redirect URI, this is basically, yeah, where the URIs can be redirected to after some successful API functionality that's pretty specific to some certain features of Spotify. We're not going to be using this right now, so you don't have to worry about that. If you're really curious, this is basically like if we're setting up some functionality that pulls something from your Spotify account, you have to then log into your Spotify account on the React app, and then maybe once you're logged in, like it'll open up a Spotify page telling you to log into your Spotify account. You log in, and then it'll redirect you basically back to the React front-end client. That's basically what it is, but for now, we're just going to enter this like basically dummy field that won't really do anything. Yeah, just pull it together. You don't have to worry about too much about what this does for now. Oops. And we're interested in using the web API, Spotify web API that is, and we understand with and agree with the terms of service. So let's create that. And there we go. And once we do that, the next thing that will be pretty fundamental is to head to settings and note our client ID and secret ID. So settings is up here. And you see our client ID right here, as well as our client secret. These are basically alphanumeric characters that serve as almost like it's similar to API keys that I mentioned before, but in this case, it's like a unique code that refers to our app. So each app will have a unique ID and secret, and we want to keep these protected. So that's why we're going to be using environment variables in the next few sections of this demo. So with this client ID and client secret, we're going to next create our .env file. So a .env file looks like this. It basically contains name value pairs, but in this format where the name is typically in all caps, and then there's the equal sign, and then the value is the follows right after that. And then typically we don't use quotes unless there are like spaces inside the value if it's a string. So yeah, let's create our .env file. And you can do that just by simply doing that. And then here we're going to create client ID and client secret. And we'll paste that directly from Spotify. And client secret is here. And remember you have to click this button to view the client secret. And yeah. Once we do that, we have our .env file, and then we're also going to run npm install .env. And basically what that did is it added this package called .env, and that basically lets us use environment variables and access them inside our React code. That's the only extra package we're installing today, so don't worry about adding any others. Um, and as you can see, it added one package. And then we're going to add some code to our veep.config.js file. And this basically like lets us work with normal environment variables. So this is what we're going to be adding. So let's do that right now. We're going to be importing .env from .env. And then we're going to do .env.config. Let's add one more. And then finally, we're going to do define. And then you don't have to worry too much about what this code does, but it basically lets us access environment variables easily inside our code. But don't get too wrapped up about the syntax. Okay. So before we get into these Spotify web API calls, we're going to be looking at a few terms right here, async and await. So async and await are basically two keywords used to handle asynchronous operations. API calls in general and other network operations in your projects are generally asynchronous because they often involve waiting for data from external sources, which can take some time. Typically, when you run some code that's really basic, it runs in a matter of nanoseconds, but when working with network operations, it can take a few milliseconds or even seconds. So when running your applications, you want things to be as fast as possible and you don't want things to freeze up, right? So by using asynchronous operations, we can allow our app to remain responsive while waiting for some network request or API call in this case to respond without freezing or blocking any other tasks that are waiting while we wait for that response. So you can see here on the right how synchronous and asynchronous operations differ. So when we use the async keyword, this basically declares a function to be asynchronous. And this specifies that the function returns a promise. Await is then used inside an async function, and this basically pauses execution until a promise is resolved. You don't have to worry too much about what a promise means, and we'll see like how we actually use these keywords below in the next section. So now we're going to be adding Spotify authentication. To do this, we are going to be creating some state variables and some React elements. But if you take a look here on the right, we'll understand actually how the Spotify authentication occurs. So, and you can also click this link to learn more about this process, but this basically is the client credentials process. So using our client ID and client secret that we found right here, our application, which is on the left, is also known as a client. It basically requests an access token from Spotify. On the right is the Spotify server or the Spotify account service. And we give a request passing along our client ID, client secret, and also something called grant type um, to the Spotify server. Then Spotify gives us back something called an access token. As you can see, we follow this path right here. And then using this access token, we can now from the client access different requests as a part of the web API. So here we pass along this access token, and then the Spotify web API returns any requested data back to us in the form of a JSON object back to us in the client in the response. And that's basically the workflow of the access token functionality. So let's add this right now. So let's create the state variable and create a button. So we're going to just call it access token, and it'll basically store the access token that we retrieved from Spotify using the useState function. And here we're just going to initialize it to an empty string. Um, and then, as we said, we have this button already created actually. And then we're going to make an API call to Spotify to get our access token. So to do that, we're going to create, oops, we're going to set the onClick handler to a function. This is called authenticate Spotify. And let's define this function right here. And note that this function we're going to define as async because we're going to be making our API call inside this function right here. Um, so yeah, let's get into that. So first of all, we're going to start with a try catch block. And if you want to just have that really simply generated, you can do that. And then air right here. And then we'll be catching air with hot. So basically, as you probably know, a try catch block checks for any errors that might run inside the try block. And if there is an error, it basically catches it right here and then runs whatever code that's inside the catch block. So inside here, we're going to set our or make our API call. So let's create a response, and then we're going to use await so we don't uh, wait for our API call. Instead, we can proceed later in the code if we want to. And we're going to be using the fetch function right here. Basically, fetch is a built-in function that helps us make HTTP responses requests in React. That's really simple and easy to use. Um, so we're going to create an await call to fetch, and the first parameter will be our URL to the Spotify um, access token link. And the second parameter will be our options for the request that we can set. So the first option will be method and will be post. The post method that we learned before, since we're basically wanting to create a new instance to get a new access token in Spotify Web API. And then we're gonna set our headers. And our headers in this case will be content type. And the content type in this case will be something like this, which may seem a little confusing right now, but it's basically a different way to send content in our body, which we'll specify right now, actually. And to do that, we'll use something called URL search params. So URL search params helps us define our body to be in the format of form URL encoded. And this is basically a series of name value pairs again, just in another format that Spotify wants us to use. So inside URL search params, we can actually set um, the body content to be similar to a JSON, and Spotify wants us to use a grant type. In this case, that's just client credentials. And then we need to refer to our client ID and client secret. And to do that, we're going to be using, oops, this keyword right here, process.env. And with that, we can access our environment variables directly by just calling their name after the dot operator. And then we can do the same thing with client secret. That's about it. And if you're wondering about what grant type means, it's basically just telling Spotify we're going to be getting the request token by passing along our client credentials, which is the client ID and client secret. So that should be pretty simple, right? Once we do that, we have our request stored right here in this const variable right here. And then we're going to be checking the status of the response, and we can do that just with this simple statement, oops, 200. And as we learned, 200 indicates that it is a success type response where the success type response indicating that the response was successful and the request was handled correctly. So in this case, we're going to then check extract the response JSON, and to do that, we'll use the await keyword in this case, because we don't want to stall our program too much. And then if the response JSON exists, then we're basically going to set access token to be response JSON.access token. And that's the format that Spotify uses. And if that's not the case, then we can print out an error. We're actually going to use console.error here, and I'll change this to console.error. Just a minor thing, but it's better for debugging. And we say HTTP error. Oops. And then we'll just pass in the response status if it wasn't 200. So yeah, this is what we'll do here. And then next, let's add our search bar. So first, we're going to see if our access token is not empty, then we're going to return a form element. So right here, you can do a simple inline statement. Let's say if the length is greater than 0, then we'll create a form. And we'll just have this form simply contain an input field and a submit button. Oops. And this button will be type submit, and that basically indicates that once you click this button, then the form is submitted. And this can just be like it's kind of a placeholder like enter a Spotify song. So for the search bar, we're just going to be searching out Spotify songs, and then we're also going to add a name, and this will just help extract the value that the user enters right here. That should be it actually. Oh, and the one thing to note is that you have to set the specify the event handler. Once you click this button, we submit the form, and on submit, we'll call another function like Spotify search. So yeah, it's the code we have here. And if you run the app at this point, okay, sorry about that. We had a quick small error. First of all, we misspelled this section. It should be x-www-forum-url encoded. And then we also had a mistake where, please fix this right now. We had .env outside of our actual project. So make sure that's inside our project folder. And with that, let's try running. And then so the goal right here is once we click this button, we go to authenticate Spotify, we make the API call using the fetch built-in function. If it's successful, we check if the response has a JSON, then we extract the access token from that JSON and then set it right there. And then once that's set, we should see our form element come up on the screen. And then once we do that, also one thing we need to do is just define our Spotify search function right here. And with that, click authenticate. There we go. We have our search bar. We can type in our song there. And once you click search, the goal eventually will be to display our song results right here below. So yeah, let's create a new state variable. We're going to call this results. And this will basically store the results that we receive for the song search results. So it'll be an empty array. It'll just basically be an array of songs represented by JSONs. So it'll be an array of JSONs. So using results, then we're going to create that. We already have our search function, but let's make this async since we're going to make another API call. And here we're going to make the web API call to Spotify search endpoint. So we're going to actually refer to the documentation right now. And we can see this is the official Spotify documentation. It has a bunch of different articles right here on the left, some reference items. We also have like some basic getting started tutorials, which can help you if you're ever stuck. So right here, we're going to be searching for an item, specifically a song. So it's basically a GET request, which you can see right here. it's a slash search. And then we have different parameters right here. We have queue, type, market, a bunch of different things. And basically, we're going to be focusing on queue. That is basically the search query. And in this case, it'll be the name of the song. We're going to be focusing on type, which is what to search for. So we'll set that to, let's see, the example is track in our case, which basically is a song. We're going to also be setting the market, which basically just simplifies things. We'll just set to the US market to make our response more readable. And we're going to not use any of the others. They're optional. But yeah, so let's create the Spotify search functionality. So we're going to begin with the same try catch block since we want to catch any errors that we might have when making an API call. Then we can just actually copy this right here and use the same syntax. This as well. Okay, so has to be a different URL. In this case, you can see in the documentation, the URL is right here. I'm going to grab that. In this case, this actually uses query parameters. So as we see here, we'll add a question mark and use that syntax to set the parameters that we mentioned, like queue, market, and type. So we can just do that like this. And we're actually going to create an inline string in JavaScript. You can do that with that character. And then you can directly put a thing right there. So we want to put our query there. We want to then have, let's see. So we have query, we have type, we have market. So type will just be track, and market will just be US. Got everything right there. Yes, so. And then you might be wondering, where do we get this query from? To do that, we're gonna have to extract the query from the form. And to do this, that's pretty simple actually. We'll just so when we create this form, we have this onSubmit event handler, Spotify search, and to use that, we're gonna have to pass in, add a parameter right here, event. Event basically helps us access information from the form once the user submits it. So once the user submits it, React will automatically pass in event, the form event that is right here inside Spotify search. And that just contains, as I said, the information associated with that form. And then we're actually going to say event of prevent default. And what that does is in React, by default, when you submit a form, it will reload the page. And we don't want that. We just want to display the search results. So this prevents that default reloading behavior. And then we're going to create a const variable query, which is what we refer to right here. And to do that, we'll extract the query form input field right here called query, and that's why we can just access it with that. Event to target basically grabs the target object from the event, the form event that is, and then dot value extracts the string that the user actually types. And then we'll just use that same query right there. And yeah, that's about it for the URL. Now this is a get, as we saw right here, get, not a post. And for headers, that's something that's pretty important. So if you take a look at this example, this uses something called curl, which is a command that you can run in Linux. And it basically is like an easy way to get like a simple web API call performed. Here we set the URL to be what we saw. Then we set a header right here, authorization bearer, then some token right here. Basically, what that does is, let's just start typing that out. So authorization bearer, and then we'll add a space there as they do. And then there's some code here. And what that is basically, I don't think Spotify says it on their page, but that's essentially the access token. As we mentioned in the client credentials workflow, let's actually go back to that slide. So on the top right here, once we authorize ourselves, we get the access token, and using that access token, we can make other requests to the web API. So this is actually the access token. We have our access token actually in our state variable right here. And this function is only called if access token is not an empty string. And it always will be a non-empty string that Spotify returns to us. So we can just simply access our access token using that keyword and then add it to bearer. Bearer just type is basically an indication of what type of access token it is. Don't worry about too much about that, but that's what Spotify wants from us. And as we mentioned, similar to API keys, this is the way that we tell Spotify we are authorized to make this call because we have this bearer access token. Otherwise, Spotify will return an error in the response. Then what we can do is we don't need this body anymore actually. Um, and then we're going to set results. And in this case, this will just be JSON. So let's take a look about what the response JSON looks like. So if it's of type 200, that's what we want. We don't want any of these errors because we begin with 4, the status code that is. So if it's 200, we have tracks, we have artists. We don't care about these since we're interested in tracks only. So let's look at tracks. Then we have, let's see, items, items of track objects. So that's what we're interested in. We're going to do tracks.items, and this will return an array of track objects, which is basically a JSON. And as we said, results is an empty array. So we're just going to set it to basically an array of track JSONs. And once we do that, let's go back to the slides. We have our search bar, performed our search. Now we want to display our search results. So let's create a div element. Just going to add some spacing here. This will contain our search results with the different tracks. We're going to have some flex styling. So let's add a class name, track results. And then this is the app.css file that is associated with app.jsx. And for this, we're just going to have a basic simple flex box. If you're familiar with CSS, this should be pretty basic to you, but if you're not, this basically just means that we are creating a flex box, which is like a very flexible container that will just store our different, like, we'll have different elements with the song information for each one. And then flex wrap basically wraps the different items if they go past the screen length. And then lastly, we're going to set a gap. Let's do like 16 pixels. And for like each song box container, we'll just set them 16 pixels apart. So that's pretty simple. We don't need that anymore, so we can close that. And then inside here, what we want to do is we want to add a mapping on the result state variable. And what that does, it basically, in React, we can create a React inliner and then use a mapping, and basically we'll map the result state variable to display each track in its own div. So let's do that right now. We're basically gonna use something called the arrow function, and that will basically it's actually that instead. So let's do that. And this will make sense in a second. So basically, results, as we mentioned, stores the JSONs, the track JSONs that is in an array. So we're mapping it, which basically does for each track, which we basically just represent each JSON object as a track variable right here. We can do whatever we want. So then let's say if there are 3 JSON tracks inside results, it'll create 3 divs, and then we can access that track JSON using this keyword track right here. So let's just inside each div that is, let's create a paragraph element. This one will just be track.name, the title of the song that is. We'll do another p element. Inside this one, we're going to be doing something a little bit more complicated. Some songs may have more than one artist, so we actually have to handle that case. We're going to use map again. This time we're going to map, basically just artist is basically, this is just a string, but this is an array of strings. So we're just going to map each string in the array to its own item, and then we can just access the name of the artist with that syntax. And then we'll finally do the join, and join them by a common space, which basically what this one-liner does is if it's an array of strings, it just brings all the strings together and separates them with a comma and a space. A really simple way to get past this little edge case right here if there's more than one artist. And then finally, we're going to create a link element, and this will have an href attribute, which basically is the URL of the link. This will be track.external urls.spotify. If you're confused about where we got this from, let's go back to the documentation. Right here, we see, oops, wrong. So inside each JSON track, under items, each one has the type where it defines an external URLs object, and then we have Spotify, which is a string. So if you just do external urls.spotify, we can get the Spotify URL for the object, which is basically the link to open that song up in Spotify. And then we're just gonna like do a little thing here where we just set the target to be underscore blank, where that basically lets us, if we click on the link, it'll open up in a new tab instead of replacing the current tab with the Spotify song. And then this can just be open on Spotify. Now for some finishing touches, we're going to be adding a key actually. So the key attribute is something that's really important in React when using map function. Key basically tells React how to uniquely identify each div that is mapped. And it just helps it with some state changes and manage how things get changed once some changes are made to this array, basically. So just to help things be more dynamic, and it's something that actually React requires, we'll just set it to track.id. And again, if you're curious, each Spotify track has a Spotify ID, which you can just access with that. And then same as name, you can find that also right here in the documentation. And the last thing we'll do is add, another class name. This will just be a track for a CSS class. And we're just going to set the background color to light blue. So for each track result item that shows up in our React app, we'll just set the background color to light blue just to differentiate each one from each other. And with that, that should actually be it. So yeah, we should have our finished product. Let's restart the server. Oops. Restart the server, go back to our app. So first we authenticate, we grab the access token. Once we have that access token, our search bar shows up, and then we can make the call to the /search endpoint of Spotify, and then we pass along our access token. We tell Spotify, hey, we're authorized to make this call and make a Spotify search. And then we can just type in something like Gangnam Style, search up a common song like that. Once we click search, there we have it. We have our results. We have the different tracks or Spotify songs that Spotify helps us pull from its web API. And you can see like each one has a unique name. Each one has different artists. And then we can also click on this link to open it up in Spotify if we choose to do so. And yeah, that's actually about it for the demo. So yeah, your button should work. Results should look like this. Again, you can see the full code in the README link below right here. And if you do want to, access other Spotify cool features, you can check out the web API documentation right here. There's a bunch of different cool things that you can check out, and into some like extra functionality that you might want to add to your project. And yeah, with that, we've learned what web APIs are and how to use them. Um, we've also covered a few different fundamental things related to them, like a client server model, HTTPS, HTTP, some extra stuff as well. And we did that cool demo. So now try to add these to your own projects and create cool features. If you do want to explore other popular web APIs, there are plenty of popular options like the Gemini Developer API, Google Maps API. There's one for YouTube, Instagram, Spotify. As you saw, there's even Twilio, a bunch of cool options out there. So feel free to check them out. See if you can add these web APIs to your project to create a bunch of cool different features. And with that, we're basically done. That's it for the workshop. Thank you so much for watching and good luck with your projects and have a great time at Hack on the Hill.